Endogenetic movements. Introduction. Earth movements. Various natural events occur on the earth from time to time. Example, floods, storms, snowfall, extreme rainfall, etc. Similarly, because of the movements below the earth's surface, natural events like earthquakes and volcanic eruptions occur. For the organisms living on earth, these events are disastrous. There is loss of life and property because of natural calamities. Let us take a look at these internal or endogenetic movements. Try this. Arrange your notebooks on each other with chalk, duster, sharpener, eraser on them as shown in this figure. Quickly take out a notebook without affecting the others as shown. Repeat the first step and give a slight push to the structure. Geographical explanation. Internal movements. Earthquakes and volcanoes occur because of the instability in the interior of the earth. This instability is created due to the movements occurring in the earth's interior, in the upper layer of the mantle. Radioactive minerals release tremendous energy in the mantle. These energy waves travel from one place to another, causing instability in the mantle. The movements are classified on the basis of their velocity, direction, and the landforms they produced as shown in this table. Slow movements. The effect of slow movements can be seen in the formation of mountains, orogenic movements, and continents on the Earth's crust. A. Mountain building orogenic. Try this. Take a 30 centimeter long paper strip. Place your hands on both the ends of the strip. Move both the hands towards each other, giving pressure on the strip. As you see, the strip starts getting folds. Geographical explanation. The strip was moved by placing hands on both ends, giving pressure on the center of the strip. This work is called compression. As a result, the strip moves and folds form. Similarly, due to pressure on the Earth's crust, movements are generated and folds are formed, as shown in this diagram. Fold mountains. Energy is transferred from the interior of the Earth. Because of these energy waves and pressure working towards each other and in a horizontal direction, the layers of soft rocks form folds. If the pressure is very high, large-scale folds are formed, of increasing complexity. So, as you can see, the surface of the earth gets uplifted and fold mountains are formed. The Himalayas, the Aravallis, the Rockies, and the Andes and the Alps are the world's major fold mountains. Try this. Take a long strip of thin paper. Hold one end of the paper in your right hand and hold the other in your left hand as shown. Pull both the ends away from each other. Observe that the paper gives way in the center. Geographical explanation. Tension and force. In this activity, tension is created when you pull both the ends away from each other. Similarly, when movements occur in opposite direction to each other, tension is generated and faults are formed in the Earth's crust. Block mountains. Because of internal movements, horizontal waves moving away from each other are formed. This causes tension on the layers of rocks, which leads to formation of fractures in the rocks called faults. Similarly, waves coming towards each other in hard rocks also form faults due to compression. When a part of the Earth's crust in between two parallel faults is lifted, It looks like a block and is called a block mountain, as shown in this figure. Block mountains are flat-topped with steep slopes and no peaks in the early stages. For example, the Black Forest Mountains in Europe and the Meghalaya Plateau of India. Try this. Take 3 notebooks of the same size. Hold them tightly on a table, keeping a distance of 2 to 3 centimeters. Remove the 2 notebooks on each end away from the central one. Observe that the middle book subsides. Geographical explanation. When horizontal movements on the Earth's surface act in opposite directions, it causes tension increasing. Tension leads to formation of faults and no continuity in the rock layers. Rift valleys. Sometimes 2 fractures develop side by side in the Earth's crust. The land in between the 2 fractures subsides to form a steep-sided rift valley, as seen in this figure. For example, the river Narmada in India, the Great Rift Valley of Africa, and the Rhine River Rift Valley in Europe. Slow movements. B. Continent building. Aperigenic movements. Slow movements occur towards the center or from the Earth's center towards the Earth's crust. Because of these movements, a vast part of the Earth's crust is uplifted or subsides. If uplifted above the mean sea level, continents are formed or extensive plateaus. Hence, these movements are called continent building movements. If the originally continental portion of the crust subsides below the sea level, it forms a part of the seabed. Do you know, when you stand on a railway platform near the railway track, you experience trembling if a train passes by speedily. Tremors are also felt when a heavy vehicle crosses a bridge at top speed. So one can estimate the tremors caused during earthquakes. Sudden movements. Sudden movements in the Earth's interior include earthquakes and volcanoes. Earthquakes. Earth means the ground and the quake means trembling. Thus, earthquake is the movement of Earth's crust. Because of the movements occurring in the interior of the Earth, tremendous tension is created in the Earth's crust. When the tension goes beyond limits, the energy is released in the form of waves, resulting in trembling of the Earth's surface. That is, an earthquake occurs. Causes of earthquakes. Moving of the plates, colliding of plates, plates sliding one below the other, forming of fractures in rock layers due to tension in the interior of the Earth, occurring of volcanic eruptions. Focus and epicenter. Tension created by movements below the Earth's surface keeps on accumulating. High energy is released at the place where this tension mounts up. This is the center of the earthquake, called the focus or hypocenter, from where energy waves scatter in all directions. The place on the Earth's surface where these energy waves reach first is called the epicenter of the earthquake, perpendicular to the focus. It is the nearest place on the Earth's surface from the focus, and it experiences the first tremor. When the tension is released at the focus, the released energy travels in all directions, coming towards the Earth's surface, in the form of seismic waves, which can be divided into primary, secondary, and surface waves seen in this figure. 1. Primary or P waves. Primary or P waves are the first to reach the Earth's surface after the energy is emitted in the Earth's interior. They travel radially at a very fast speed from the focus of the earthquake. Rock particles subjected to a P wave move to and fro in the direction of waves, so these waves are called forward-backward waves. These waves can travel through liquid, solid, and gaseous states, but while traveling through liquid medium, their direction gets changed. It is because of the primary waves that the buildings of the Earth's surface move back and forth. 2. Secondary or S waves. Secondary or S waves reach the Earth's surface after the primary waves. They also scatter in all directions from the focus of the earthquake. Their velocity is less than the P waves. Particles in their way move up and down in the direction of the energy transfer. These waves can travel only through the solid medium. They get absorbed as they enter the liquid medium. Buildings on the Earth's surface move up and down because of these waves. They are more destructive than the P waves. 3. Surface or L waves. Surface or L waves are generated after the main P and S waves reach the epicenter. They travel in the direction of the circumference of the Earth along the crust. They are highly destructive. Seismogram. Look at this seismogram. It is an instrument through which this graph showing the movement of seismic waves, seismograph, can be generated. After studying the graph, the magnitude of the earthquake is known. Try this. Hang a heavy bag or pouch on the hook of a spring balance as shown. Pull the bag down and release it. Observe the spring and note its to and fro movement. This is similar to the P wave. Now, observe the students standing holding the ends of a rope. If one student jerks the rope up and down, observe the formation of up and down waves, like S waves. Spread rangoli on a large plate. Flick the lower side of the plate slightly with your fingers and observe the powder fly up along the circumference of the dish like L waves. Effects of earthquakes. Cracks, fractures develop on the ground, causes landslides which lead to rock slides. Sometimes groundwater changes its course. Example, wells may fill up or dry up. Some areas get uplifted, others subside. Tsunamis generated in oceans can cause great loss of life and property in coastal areas. In snow-covered areas, avalanches occur. Buildings collapse and loss of life and property occurs. Transportation routes get disrupted. Communication system collapses. Volcanoes. Hot, solid, liquid and gaseous materials are thrown out from the mantle of Earth onto its surface in a process called volcanic eruption. During this process, ash, water vapor, various types of poisonous and inflammable gases, hot molten magma, etc. are thrown out. When the molten magma comes out on the surface, it is called lava. On the basis of the type of eruption, volcanoes can be divided into two types. 1. Central type or conical volcano. During eruption, the molten magma comes out through a pipe-like vent inside the Earth's surface as shown in this figure. The lava spreads around the mouth of this vent when it comes out. As a result, cone-shaped mountains start forming and conical volcanic mountains are formed like Mount Fujiyama in Japan and Mount Kilimanjaro in Tanzania. 2. Fissure-type volcanoes. During eruption, when the magma comes out from many cracks, fissures, it is called a fissure-type volcanic eruption as shown in this figure. The molten material coming out with the eruption spreads on both sides of the fissure, forming volcanic plateaus like India's Deccan Plateau. Always remember, three types of volcanoes can be identified according to the periodicity of the volcanic eruptions. If the volcanic eruptions are regular, even in the present times, then such volcanoes are called active volcanoes. For example, Mount Fujiyama in Japan, Mount Stromboli in the Mediterranean Sea. When a volcano has not erupted since long, but may become active suddenly, it is called a dormant volcano. For example, Mount Vesuvius in Italy and Mount Katmai in Alaska. Barren Island in the Andaman and Nicobar Islands to the southeast of India, long dormant, has started erupting in February 2017, emitting dust, smoke, mud, and some lava. Those volcanoes which have not erupted in the past since long and are not likely to erupt in the future are called extinct volcanoes, like Mount Kilimanjaro in Tanzania. Do you know? Indo-Australia, Africa, Eurasia, North America, South America, and Antarctica are 7 major plates which make up the Earth's crust. Oceans and continents are spread over these plates, which move in various directions, depending on the compression and tension formed in the interior of the Earth. Geographical explanation. Look at this figure. You will understand that plate boundaries are directly related to areas of earthquakes and volcanoes. Most of the volcanoes are located on the plate boundaries, as also the earthquake zones. The part of the plate which slides under the crust is subject to subduction, that is, loss of materials. Such boundaries are called plate-consuming subduction boundaries. In areas where new material is coming up onto the Earth's crust, they are called plate-creating constructive boundaries. Both processes shown in this figure happen continuously. Effects of volcanoes. Volcanoes have the following effects: loss of life and property. Sometimes tsunamis get generated due to volcanic eruptions occurring below ocean floors. Dust, smoke, ash, gases, water vapor, etc. remain in the atmosphere for a long time. This creates imbalance in the environment. Land may become fertile due to volcanic ash. Many minerals are found near the Earth's surface because of lava. New land is formed due to volcanic eruption, or at times an island may even disappear. Lakes are formed at the mouth of craters of dead volcanoes when rain water accumulates in them. Do you know Barren Island, Andaman and Nicobar Islands are located to the southeast of the mainland of India. On this archipelago lies the Barren Island, India's only active volcano. This volcano was dormant for a long time, but in February 2017 it started erupting. Mainly dust, smoke and mud is coming out of this eruption along with some lava.